I'm going to be reviewing today some of the lighting design techniques we talked really briefly on last class, as well as discussing luminaire types, which we also just talked about shortly, making sure we cover those more in depth, as well as covering some new information about sustainable lighting. So to start, I'm going to be talking about the first lighting technique, which is called wall washing. Wall washing creates an even wash of light on a wall surface. It is most appropriate for a matte type surface so that you don't end up with reflected glare because these lights are shining sort of directly on that wall surface. They might be used for highlighting artwork or sculptural architectural features. You can see in this image it is highlighting this logo on the back wall, so providing a nice even wash of light so that there is your eye is drawn specifically to that spot on the wall. Wall washers provide an even beam of light. Part of the wall washer fixtures, which is what the fixture type is called, that actually creates this type of lighting effect, and it is concealing some of the beam of light that leaves the fixture to push the light directly onto that wall surface. You can see in this next image that this is sort of an example of bad wall washing. So they were trying to highlight this logo outside of this restaurant in addition to the stone surface, and you see these very bright points of light. So it is less successful than having that nice even wash of light on the wall. You have to be careful with both the type of fixtures you select and the placement of the fixtures. You don't want them too close to the wall because otherwise you will end up with this sort of scalloping or hot spot effect created by these lights. The next technique is referred to as grazing. Grazing, I guess, in essence, is a type of wall washing, but in this, we're attempting to achieve a different effect by really placing the light extremely close to the surface of the wall to emphasize a texture or sculptural quality of that wall surface. You never want to graze painted gypboard or a particular wall type where you do not want to see the inconsistencies, because really what this is doing is highlighting texture and inconsistencies. So if you're trying to show a nice, flat, even wall surface, that's when you want to use wall washing. That's going to not highlight these imperfections, whereas grazing is going to sort of push the light down the surface of the wall, and you really start to see those textural qualities to it. Here you can see another example highlighting this wall surface, and you can see the light fixtures themselves would be located up in that slot up against the wall. I'll show you an image of a luminaire type in just a second. Here similarly we can see the light placed right up against the wall, highlighting that textural surface in this hotel room. Then of course another example of a bad technique where they're trying to incorporate grazing is here, and that's only because we're not seeing that nice even wash of texture. We're starting to see these hot spot points, which really it's pretty even here, meaning even placement. They're spaced appropriately, so it's maybe not as bad as the previous example I showed, but in general it would be really nice if just that whole wall had showing like light pushing down from the top and showed that texture of the stone. This is really what a luminaire would look like that's grazing, so you can see it's mounted right up against the wall, and you don't see the bulb, you don't see the light fixture. It just creates this little slot of light that pushes the light down that wall surface. Both grazing and wall washing often come from the ceiling, but like we saw in the hotel room example, the grazing came pushing light upwards and to highlight the surface from below. So we want to be careful of scalloping like we saw previously. If lamps are spaced too far apart, you end up with dark spots between them. To minimize scalloping, you just want to be careful about the spacing of the lamps, and we'll talk about those more when you start actually placing lamps onto reflected ceiling plans that we'll be working on later this semester. Here's an example of that undesirable scalloping, and you can also see there's an issue with the color temperature here. So meaning the very last light we see has a warm color tone, the middle is more of a greenish, and the one closest to us is white. So we want to make sure we maintain proper color temperature as well as avoiding this scalloping effect that can be distracting. We also might use lighting to create focal or concentrated light when we want to highlight something, and particular bulb types are better for this. We talked a lot about how we can control incandescent sources to push light onto objects in a more precise way, and this type of light, you're heightening the shadows and you're really showing the form of some sort of an object. So now we'll specifically talk about luminaires themselves. A luminaire, when I refer to that, means the entire housing, everything that contains the lamp and controls it in some way. The luminaire might include lenses or reflectors that help to shield occupants from direct glare. It also will include transformers or ballasts, which we talked about as additional items that were required for certain lamp types, and the wiring itself. The luminaire will have a significant impact on how the lamp distributes the light within a room. In some cases, a luminaire may be selected to fit within the aesthetic or add to the design of the space. But really, first, what we want to be thinking about is how are we lighting the room? What are the important parts of the room we need to light? Do we want even lighting? Do we want specific focal lighting? And then what are the right luminaires to choose to do that? In some cases, the luminaire might be completely hidden, only serving as a facilitator to control the light. So like we saw with the grazing luminaire, it's not providing any decorative effect in terms of being like a chandelier or sconce. All you see is the light and how that light is coming out of the space. Here you can see as well how a recessed light will be pushed up into the ceiling. You can see different parts of that luminaire include the housing itself, which holds the bulb. It's pointing out the bulb. It's showing the structure of the ceiling and the junction box, and we need to be aware of what a junction box is. It's often referred to as a J-box in construction drawings, but essentially it's where the wiring comes in from the building and connects directly to that light fixture. So you need to know where these junction boxes or J-boxes are placed in a construction project to know where you can place your lighting. And you will be identifying these as a designer on plans. So you need to be familiar with that term. The baffle that you're seeing in this diagram here is actually a baffle is sort of a stepped feature, and just like how we talked about when we were talking about how when light bounces off multiple surfaces before it enters a room, it helps to diffuse it and not create that very direct light which can cause issues with glare. A baffle does just that. It's just a little textured surface that allows light to bounce off of it before it comes out of the fixture. Here's an image of a J-box or a junction box. So it's nothing exciting. It's just showing the wiring. It's where the electrician would connect your light fixtures that you specify as a designer to the electric that's coming in from the building. And one J-box is required per light fixture. When we talk about track lighting or sort of long lights that might be connected together, sometimes they all will be controlled by one junction box. But in general, you have one junction box per light fixture. So you can see the definition here. Junction box houses wire runs which are split or joined to bring power to electrical devices. And in this case, we're talking about lighting. So some luminaires may be off the shelf, others might be custom designed by the designer, and that's like what you're doing for your project. Custom designing should be a collaborative process with the manufacturer. They often have a lot of better ideas about how to do the technical parts of the designing, whereas you might have an idea of the aesthetic. But in the case of your project, you will be considering both the construction of the luminaire, the aesthetics, and how the light is coming out of the fixture, in addition to the technical requirements. There are some designations to ensure that the lighting we're selecting meets particular codes, and the first is UL listing. UL stands for Underwriters Laboratories. It's a nationally recognized independent product safety certification organization. Essentially what they do is they take products into their labs, they check them using a variety of tests, and then they approve the product for the market. So things that they're looking for lighting are to make sure that they don't produce too much heat, so they're not going to cause fire. They might test them to make sure that they're durable, especially if they're for outdoor use. So there's a lot of different ways that they are tested, but if you select something that is UL listed, you can feel confident that you're selecting a safe and reliable product. Another designation that we talked about last semester when we were talking about sustainability is Energy Star. Energy Star is a voluntary labeling program, so it's not a code thing. It's more just if you want to have a more sustainable product, you would make sure that your product and your light fixture meets particular specifications to have it labeled as Energy Star. Energy Star was launched in 1992, and basically it helps customers to determine the more energy efficient products on the market. So you will see this symbol directly on both light bulb boxes and the luminaires. So now we're going to talk about the different luminaire types and how they're placed within an interior. First of all, the common materials used to create luminaires are steel, extruded aluminum. Metal is very common just because of its durability, and particular types of metal you want to choose based on their ability to conduct heat or lack of conducting heat. So the fixture type we're going to talk about first is a recessed fixture. A recessed fixture, as you're probably familiar with, is recessed into the ceiling. It aligns with the face of the ceiling, and usually the majority of the housing is actually up in that ceiling plenum, so we don't see that. We just see sort of this hole of light, and it can be square or round, and sometimes the fixture projects a little bit slightly, but that's usually referred to as semi-recessed. So here you can see a picture of some recessed fixtures actually located in the ceiling surface. Here's an example of a square recessed fixture, which have become a little more common in contemporary spaces. Another image of those square recessed fixtures and how they would look actually within an interior space. And this would be called recessed as well. So recessed don't always have to be little round circles or squares. It might be a long linear recessed fixture. And the actual space in which the light is coming out of is referred to as the aperture. So the aperture can range in diameter or size of the opening. For the round recessed fixtures that are the most common, you might see them with a 2-inch to 8-inch aperture. 4 and 6 are the most common aperture. So it's essentially that diameter where the light is coming out. Semi-recessed are similar in which the housing is mostly up in the ceiling, but now it's a little bit adjustable. So part of it we see sticking out of the ceiling, and we can actually adjust the direction. So if you have an area where you're trying to highlight something, retail settings are really good to have these kinds of adjustable lights. So as things move on the retail floor, you can adjust the lighting to highlight those specific products. And then another type of recessed is referred to as an eyeball fixture. Similarly, it's semi-recessed. You can maneuver it in 360 degrees and point it in multiple directions. These are not as common anymore. They were sort of more common in like the 70s and 80s, but you'll see them occasionally, and you can see them in a kitchen space here where they wanted to use more directional light. In some cases, the trim around the recessed fixture may be specified. It might be specified to be more decorative or more simple. You almost always have to choose the trim type when you select a recessed fixture. It could be silver, it could be white. Usually you want it to just blend in with the ceiling, but you do see here that there are some decorative options. If you choose to have trimless, so you can see in these installations, you have no trim at all. So this is more expensive just because it's difficult labor-wise. Whoever's installing your ceiling, your contractor has to get those openings just perfect, and they have to plaster in right up to those edges and make sure that they are just the right size. So while there aren't additional pieces and you don't have the cost of that trim piece, you do have a lot more involved with the labor of this. The next type is a surface-mounted fixture. It could be mounted directly to the ceiling. It is not recessed into the ceiling. So now these are used in instances where there is not much room in the ceiling. If you have very low ceilings, not a very high ceiling plenum, and you need to mount directly, sometimes on particular types of wall material like exposed brick, when you can't really put the wiring into the brick, you might use a surface-mounted fixture and then run the wiring on the outside of the brick, and then hide it with some sort of a concealment. But regardless, surface-mounted are, as they say, mounted to the surface. In this case, the J-box is usually behind the wall, but sometimes mounted to the surface of the wall as well, and is just hidden behind the fixture itself. The surface-mounted could be on the wall as well, and when it's mounted to the wall, we refer to those as a sconce. And here are some examples of sconce fixtures. In this case, you can see it has a diffuse cover on the front. It's pushing light both up and down on the wall and providing a little bit of interest. Some more examples, you can have even more decorative, some a little more traditional. So there's a lot of options, and sconces tend to have that sort of decorative aspect to them, adding to the aesthetic of the interior space. The next type is pendant. Pendant fixtures are fixtures that are suspended from an extension rod or cable off of the ceiling. They could serve as an uplight, bringing light closer to the ceiling and bouncing that light off. They could serve as a downlight, bringing light to the work surface. They could be very decorative. Chandeliers are a type of pendant. They come in many shapes and many sizes, from tiny pin spots to huge sculptural pieces. The J-box is usually in the ceiling, and then the wires come through the suspension rod, bringing the electricity to the chandelier or pendant. And you can see here some small decorative options, very different types here, some that are a little more industrial, look like something that might be used in an office or a school, whereas this one is a little more rustic looking, could be used in some sort of a restaurant or retail setting. So usually the pendants are where you get to have a little more fun, and pendant is the type of fixture that you are going to be working on specifically for your project, as well as coordinating sconce fixture, I believe. There are lights that you can mount in the ground. So now we're looking at something that's sort of recessed, but instead of in the ceiling, it's in the ground. These are often used as landscape lighting outside. Obviously, if they are used on the exterior, there are specific listings for if it is appropriate for exterior use, because water could get in there and temperatures change and fluctuate. So they're a lot heavier and a lot more structurally sound than maybe something you'd use on the inside. Here are some interesting examples of ways to incorporate in-ground lights. A cove or slot light is mounted into an architectural feature, such as a cove or slot, in the building itself. They usually utilize a linear fluorescent or an LED tube light to create a continuous line of light. It's indirect lighting because it's bouncing off these ceiling or wall surfaces before you see the light. And you never really see the fixture, you're just seeing where that light's coming from. So now the fixture, while it's important in the way it controls the light, it doesn't matter about the aesthetic of it. So you want to avoid dark spots or breaks in this type of lighting by connecting and creating these continuous lines of fixtures. Here's an example of a slot light along the edge of this stairwell. Track lighting. So track lighting can cross over many categories, but because it could be recessed, it could be surface mounted, or it could be pendant mounted. But in general, what track lighting means is you have many different adjustable track heads, as they're referred to, on a long line, and you can usually slide them to create closer or farther away spacing, as well as adjust them to point in different directions. So here you can see a recessed track lighting. Track is extremely popular for retail environments, also popular in museum or exhibit design. You'll see it in grocery stores, that type of retail setting, anywhere that you need to have common adjustability. Here's an example of a surface-mounted track fixture. And this would be an example of suspended or a pendant type track fixture. So it's not mounted to the ceiling or recessed. Now we're pulling it off and we have those connection points to the ceiling. This is referred to as a monopoint. It's essentially a single suspended track fixture with one adjustable head or stem. Here's an example of how monopoints were incorporated into this kitchen. So because of this curved ceiling, they couldn't put like a flat track fixture there. So instead they just chose to have 3 adjustable monopoints. This is referred to as a barrosol ceiling. A barrosol ceiling is a type of ceiling in which the entire ceiling plane is illuminated. So you use some sort of a translucent material, and behind it you're usually placing lots and lots of lines of fluorescent lighting or LED. You definitely want something energy efficient because accessing these lights later is very difficult. So you want something that you don't need to change the light bulbs often. These are often used when you want to create very even lighting, or in this case you can see it's used to add this sort of decorative fish pattern to the ceiling plane. Here's another example in this conference room. So they wanted nice even lighting throughout. They created this recessed, they recessed the fixtures up behind this diffuse panel, placed the panel over top, and now you just have this glow of light above the table. So we've talked before about how we use light within the space, downlighting or uplighting. In this particular image, you can see that there's a number of downlights. We have some recessed, some surface mounted. We also have some indirect light, which is the cove light in the central square feature in the space. Downlights tend to have a round or square aperture, Specifically, a type of downlight is called a troffer. A troffer are what you see in standard institutional settings. They're usually 2 feet by 2 feet or 2 feet by 4 feet. They fit into the drop ceiling type plane. They're often in the design world called 2x2s or 2x4s or troffers. But they are used as part of the drop-in ceiling that's suspended from the slab above. You're probably starting to become more and more familiar with ceiling materials, and this is one type. And these are the type of light fixtures that fit into it, and they're used so often because they're very inexpensive. They create nice, even lighting for institutional and office-type settings, and they're very easy for developers to put in and then lease out their space because it's very simple lighting. Uplighting, conversely, as we've talked about, pushes light off the ceiling plane, and that's how the space is illuminated. So we never see the bulb. It's very concealed, and you can see it works well in office spaces in which you're not having direct lighting, you're avoiding glare. In the case on the right, you see that it's used to actually highlight this interesting molding onto the ceiling. You always want to make sure when you're using uplighting that you're using a very light finish so that we're reflecting as much of that light as possible, because we know that dark surfaces will absorb the light, whereas light finishes will reflect it off. And then there are some fixtures that actually push light both up and down, and that's direct, indirect. So you can see in this case, you can see the ceiling illuminated, but you can also see some light coming through the bottom of the fixture with the diffuse panel. So there are some parts of luminaires that allow us to control or shield light. One example is a baffle. Baffles shield light in one direction only. So basically they create this textured trim piece that fits in there, and the light bounces off that before it comes out. You can see in the right, in the little text panel, it says, the commonly used black baffles reduce glare but also cut light output. So you have to be careful because you will lose some light, but in some cases it's more important to avoid that glare than to lose a little bit of light that is absorbed by the black surface. If you really want to avoid any of that light absorption, then a white baffle would be preferable. Here's another example of baffles that would fit over a long linear type fixture, either a fluorescent or LED. And then there's louvers. Louvers are very similar, but now instead of just having the shielding the light in one direction, you have crisscrossing patterns. An egg crate louver, which is on the left, is made up of sort of these blades. They could be plastic, they could be metal. They intersect in a checkerboard pattern, and they block light rays and prevent glare, similar to the baffles. They're bouncing light off. They're either absorbing some or reflecting some, depending on the color you choose. So that's generally the overview of what we would cover when we talk about luminaires. I will post those notes online. And now I also want to talk a bit about daylighting, sustainable lighting strategies, and lighting controls. So the key goals when we're thinking about sustainable lighting design is to both maximize daylighting, reduce our use of non-renewable sources, control the use of renewable products, minimize air, water, and soil pollution. So we need to think about how will our light sources be disposed of at the end of their life. We want to eliminate toxic substances, be sure that lamps are recycled, and reduce light pollution and light trespass. So the definitions of those, if you're not familiar, light pollution is excessive illumination in the sky from electrical sources. And that, in urban environments, we tend to have more lighting. We're using lighting for external purposes, for landscaping, for lighting buildings, and it produces a lot of excessive light. So we're wasting a lot of energy, as well as it can affect migratory patterns of birds, and it has a lot of issues, so we have to be careful about how much light we're pushing out into the sky unnecessarily. Light trespass is specifically when unwanted light sources from one property direct light into adjacent properties. So whenever we're putting light on the outside of the building, we need to be very careful about the direction that light focuses and shielding that in some way. We really want to think about the control of our light sources. Daylight is defined as any light produced by the sun that strikes the earth directly or indirectly, meaning it reflects off the clouds or buildings or trees before reaching the ground. When light is diffused by clouds or other particles in the atmosphere, it is more commonly referred to as skylight. And this is in contrast to sunlight, which is light that directly comes from the sun. So sunlight we have to be more careful of because it can create more glare than the skylight, which is already reflected off something. It also might be referred to in general as natural lighting. So there are a number of considerations when we're planning to use daylighting in a space. Sometimes as designers we have very little control over placement of windows in the building and other architectural features, but in general we are trying to ensure that we have some control and can be part of those decisions. We need to be careful because not all daylighting is good daylighting. So in this case, we might have daylighting, but we also are using electric or artificial sources when they're on, and we don't need those. We need to be cognizant of the building orientation and footprint, and we need to ensure that the technologies we choose minimize glare and we shield the daylight in some way. Good daylighting uses diffuse light from the sky. It uses daylight as the primary source of illumination, and it integrates daylight and artificial lighting appropriately. One of the most important things, I know we talked about this a lot last semester, but building orientation can really affect our ability to use daylight effectively in our space. So the positions of the windows on the building, the orientation of the building, and its proximity to other buildings can affect the control devices required. Daylight that comes in from a northern exposure is much more diffuse and not as direct, so we don't need to be concerned about that as much when we're using it. As we know, the south facing is the best. It brings in sun during the winter months, so we get a little bit of warmth from that as well, and it's also not as direct. Whereas the east and west can be very hot and also very intense, so we need to control that light more. Placement of the windows or openings within a space can significantly change the ability to appropriately use daylight in the space. A higher window will allow light to spread farther into the space. If these windows are then also surrounded by light-colored finishes, the light will reflect more off these materials in the space. So you can see how effective these high windows are in really pushing light into the space and avoiding having direct light shining on the desk surfaces. And as I mentioned, when you provide light-colored finishes around those window surfaces, now the light's bouncing off, reflecting, and pushing that light into the space and creating a nice diffuse, even lighting. Bringing daylight in from above can provide that deeper penetration of light into the space. We also want to think about the window well around the space. Again, really what we keep coming back to is having surfaces for the light to bounce off of before it gets into the interior is what is most effective here. So we see that this deeper window well can prevent glare and allows us to bounce that light off those areas before it gets into the interior. Daylight also takes into consideration both providing a view and a connection to the outside world. There are many studies that have been done that prove that allowing for a view within a workspace, a healthcare space, education space, anything like that can provide significant psychological benefits. And here are just some statistics to support that. They say that in retail settings, studies have been done where when there's adequate daylight, they have greater sales. In educational facilities, that test scores are improved. So there is research to support how important it is to incorporate daylight into our space. And as we learned in our first lecture, it's very useful if we provide a far-off view in order to prevent eye fatigue and rest, because the muscles in our eyes are constantly contracting while we perform difficult tasks, accommodation, and so when we have somewhere for someone to look off to into the distance, we help to allow their eyes to rest and to provide a better, more comfortable workday for them. We also talked about circadian rhythm, so providing this connection to the outside allows us to visibly see the time of day and therefore maintain that circadian rhythm. And they've even established some laws with recognition that access to daylight is critical. In 1916 in New York City, they created a law that limited the height of buildings, providing setback requirements as well to ensure that some natural light could still reach the sidewalks. Other things to consider before I talk about the daylighting controls here are that daylight has significant health benefits. It offsets seasonal affective disorder, which is why in the winter we feel more depressed and usually a little more lethargic and such because we are not receiving as much sunlight. Sunlight also provides vitamin D, but we need to be careful because it can provide some harm like UV radiation, which leads to skin cancer. So one thing we can do as designers is select lighting that reduces UV rays. So we still get the views, we still get some light, but we prevent the harmful UV rays from entering the interior. We have to be cognizant that daylight increases heat within a space, which can be nice during cold months but is a problem during hot months. So we also need to be careful about the type of glazing. When I say glazing, I'm referring to the glass, and also controlling that light when we need to in particular times of year. Avoiding the direct light coming in will also help to prevent the fading of finishes or fabrics within our interior space. Natural fibers like silk, cotton, and linen are especially susceptible to damage, so we want to not have light pouring in on these finishes and then them losing their quality. So we want to choose to use daylight as much as possible because it's helping us to be more efficient, and also when we're talking to our clients, it's helping them to save money because it turns out daylight and sunlight is free. We aren't paying for them like we are for our electric bill. So daylight's variable depending on the time of year. We can't control it as much as we can other sources, but we do have some methods of control, and these could be interior or exterior controls. So interior, we can add draperies, we can add shades, and we can add blinds. These can be decorative in some way, or they can just be used to control the light. So there's lots of different methods of interior lighting control. And then we have different window types that we'll be considering, and that includes skylights. Skylights are the windows that will be on the top surface of a building and deliver light into the space. They're often tinted or frosted to help prevent glare. It is best for skylights to not be on a completely flat surface, as water and dirt and debris can collect on that flat surface, so we usually have them popped up at an angle. They might be domed or slanted, and they really shouldn't be more than 5% of the ceiling area. So here you can see some of those particular qualities of skylights, and showing that when you have a splayed, so an angled opening, we're helping to bounce that light off before it gets into the interior. We have standard windows, so standard windows that we're typical to seeing on the vertical surface of a building. They allow for daylight to come in and are also the best windows to provide that exterior view. One type of lighting control that we might apply to either the inside or the outside of the building is referred to as a light shelf. A light shelf is used as part of the window system. It reflects daylight off the shelf and onto the ceiling. It's good for the reduction of glare and direct light. These horizontal surfaces could be on the interior or exterior, as I mentioned, and here are some diagrams of how they work. Here's an example of some that are on the exterior. And the next type of window is referred to as clerestory. Clerestory are those high up windows that I mentioned really push light into the space and usually are a little better for preventing direct glare. They're on the vertical plane and they allow light in and can be configured to redirect or reflect light. A roof monitor is sort of a bunch of clerestory windows that are set into the roof that face one another. So it's sort of a type of clerestory windows, and you can see two examples here. And then I included this image because as designers we need to find ways to diagram our daylighting techniques. Where's the light coming in? What surface does that light bounce off of before it reaches the interior space? So as we start to explore these techniques, we should also be thinking about how we would visually show them to our clients to know that we're incorporating them. We don't want to just show, okay, we have windows on the building. Great. Windows isn't all that we need to perfectly control the daylight and allow for light to both come in but be controlled. So how do we also show there's windows, but we also have some of these control methods? And a few other energy efficient strategies and controls include daylight sensors, occupancy sensors, and then other lighting controls such as dimmers. Dimmers we're very familiar with, probably used in many spaces that we use every day. They conserve energy, but they also might be used to improve the aesthetics. So you may choose to have a dimmer within a space because it's a restaurant and during the day you want the lights up, but in the evening you want to reduce them and create a particular mood. Not all lamp types can be dimmed. Incandescent can, but other lamp types must be listed as dimmable. Otherwise, you will have an issue with that lamp and it may die early on you. Occupancy sensors, they turn on or off the lighting depending on whether there's movement or heat in a room. They reduce the amount of lights that are left on accidentally when someone is not using a space. It'll shut the light off. But it can be frustrating because I know some people who have had these in their office, if they sit too still and the sensor is not detecting movement, it'll shut off even if they're still in the space, and then they have to move around to get the light to come back on. And then daylight or photo sensors actually detect the amount of illumination in a space. So they will continually adjust the levels of the electric lights to ensure that appropriate light levels are met, but it's not using more artificial lighting than necessary. Maintenance and cleaning can greatly affect the light output of artificial lighting. So dirt, dust, and debris can reduce the lumen output. So we need to be careful to also have maintenance of our light fixtures so that we're not losing the ability to have that light output. So then I'm going to talk about some energy efficient artificial light types. The most common that people are familiar with right now are LEDs. Early on, LED lights were questioned and criticized because they were very expensive, and they still are fairly expensive, and they have very poor color rendering. Now, this has improved. It is not as great as incandescents, but it's getting close. But they're extremely energy efficient. They're very adjustable, and so we are looking at better costs. In terms of cost, you can purchase a standard A-lamp incandescent bulb for about $1. An LED replacement, so what you see here, some of these may run $12 to $25 per bulb, but you will not have to replace them probably in your lifetime. In terms of energy efficiency, an LED will generally use 80% less energy than incandescents, so there is this trade-off. So when you're pitching LEDs to a client, you need to make it clear that there will be more upfront costs, but they have a long-term electric bill savings. So LED itself stands for light emitting diode. They are made up of chemicals that determine the light that they emit. There's phosphors within them, and basically these chemical phosphors inside the LEDs are excited by the electricity that is pumped into them, and then they glow. It's sort of like the fluorescent technology we talked about, but now we're looking at a much smaller scale. And the phosphors can determine the color temperature of the light. So there might be blue phosphors that make it a little bit more of the blue color temperature, whereas some might be a little more warm. The warm phosphors are harder to come by, and that's why LED has traditionally been known as sort of a bluer, cooler light. And the warmer ones are more expensive and less efficient. So we see those less often, but because incandescents are getting pulled off the market, companies are finding ways to create this warmer LED light. Let's see. So here's the basic structure of the LED. The parts are the chip. The chip has the crystals that have a certain number of electrons, and when those are charged, they produce light. You can see in the image there's a negative layer, there's a positive layer, and they transform energy into a visible light. Most luminaires you'll find use more than one LED chip to light, so it's called an LED array. So when you saw those LED replacement bulbs in the previous slide, there were probably multiples of these little LED chips inside of it to create the light. You have optics inside. Those are the components that help control the light. They might reflect or refract the light, which we talked about last class. And then LEDs require a driver. What a driver is it converts the power or voltage to an appropriate current level. It's sort of like how we talked about low voltage lighting, like halogens require a transformer. LEDs are so small they can't handle the amount of energy coming in from the outside into the building, and so this driver helps to make compatibility between the electric coming in and the electric required to light that light source. The other important thing about LEDs is because they're not like incandescents where they have a filament that's burning and producing heat, they still do produce heat out the back of them. So in a lot of cases you'll see something which is referred to as a heat sink. Basically what it does is it absorbs that heat and disperses it. It usually has fins, which is what they're called. So you can see that sort of textured fin-like look to the heat sink. If you don't have a heat sink on your LED light, it might dim or burn out. So if you're choosing to use LEDs for the design of your fixture for your project, you want to make sure you have something to help to disperse this heat, some sort of heat sink. The heat sink is typically designed as part of the light fixture. And you often see them, like I said, in this fin type shape. You can see them here. This is LED track lighting. So you see on the left, it's created this sort of elongated, pointed fin-like structure out the back. On the one on the right, you see that it's just elongated structure, and you can see the little sort of baffly fins, and that's helping to disperse that heat. So it can be very integral and designed into the fixture. You also see on the one on the right, those 3 spots. Those are the 3 LED chips that make up this fixture. So like I said, rarely do you just have a single little one. Usually you have multiples that make up the light fixture. LEDs also work very well to create long linear tracks of light. In that case, you just have many of those chips up next to each other in a long line. So these are LED lighting solutions from 3M. And you can see that they don't always have to be little points of light. LEDs do have the ability to be dimmed, but you have to have a dimmable driver. So again, you need to make sure you look at the equipment you choose so that it says that it is able to be dimmed. LEDs initially were most popular in the commercial market because of their energy efficiency. They meet the stringent energy codes. They are becoming fairly standard in a residential market as well because they are adjustable. Here's an example of what product that Philips Lighting created. It's called Hue. I actually have it in my own house, and it's really fun to play around with. But essentially, they're these energy efficient LED bulbs, and you can adjust the coloration and intensity of the light on your iPhone or iPad. You can pick the colors, and that same light bulb, because they include all the phosphors inside of these light sources, and you're just selecting which ones are illuminated or excited based on your selection of the color on your iPad. So I'll show you more about this later, but I just wanted to bring it to your attention, and you can check out, they have an awesome website for Philips Hue. It's also helpful to have this adjustability because studies show things like people work more efficiently in a cooler light, but they're more restful in a warm light. So instead of having to put new light bulbs in different areas, you might just want to adjust the light right in front of you. So you can achieve these same effects using the same bulb. Now I just want to briefly touch on OLEDs, which are the newest type of lighting in the market and are becoming more and more popular. Similarly, they're very energy efficient, just like the LEDs. OLED stands for Organic Light Emitting Diode, and they're called organic because they're made up of a carbon-based material. That carbon-based material is housed within thin glass, and then there's electric contacts inside of it. Similar to the LED, we are basically exciting a material inside of there and making it glow. They're very two-dimensional. They're extremely flat. They're very soft, so we can't use them as points of light, and they're very bright. Here's an example of an OLED panel. The technology is so new that they still come in very small sizes. Like I said, they're extremely, extremely thin, almost thinner than a human hair. Once they're inside the glass, they're a little bit thicker, but the material inside of these is extremely thin, which makes them really interesting for particular applications. Their CRI is not great. Color rendering index, it's about 80. We know that 100 is the best. And they do have the ability to be dimmed. So here are some interesting applications. You can use them in decorative lighting, but you can create really interesting patterns of light. One of the examples of a Luminaire competition that I posted online from one of my previous students is OLED, so you can see how that's incorporated into a Luminaire design. Another example of an OLED light fixture. Here's another example as well. So they're still very expensive. They are usually only accessible for high-end projects, but that will probably start to change. And because they create such a diffuse, even light, not a pointed light, they're not for task lighting. These are more for decorative or for very even lighting in a space. But because they're so flat and flexible, they have some interesting applications. On the left, you can see we could use these in place of reflectors. We could actually make reflectors glow, whether it's someone that's biking or a construction worker, because they're thin. There's some really interesting installations where people have used them in fashion designs because it takes almost no power. They could be powered off a small battery, so you don't necessarily need them to be plugged in or hardwired into a building. You can also use them, you could use them in place of a window. So let's say, because you can see through them because they're glass, so you could place an OLED on the window, see through it, but then at night, all of a sudden, the window would glow and illuminate. So there's a lot of interesting things to think about. This is the type of technology used in the iPhone. That's why it glows in the way it does. So we'll talk about these more, but this is just sort of an introduction to this really interesting technology and also something to consider for your project, for your Luminaire design.